Hello and welcome back, my dear students. In this section 13.1, I'm going to cover with you the basic concept of double integrals, how to solve some simple questions about double integral. So what you used to take in your Calc 1, even at the beginning of our course, just you used to deal with one integral only. Now we're going to expand that concept on how to deal with two integral, with double integral. So you will see just not only the notation will be double integral, and you'll see not only dx, you'll see dx and dy. So basically, we're just integrating the area under this curve to get the volume as the double integral. Now we have this definition. And this definition, what do you see? I have the integration of the integration. So it's just like the integration of the another integration. So usually we start with the inner one. We do the inside here with respect to y, and then after we're done, we do the integration with respect to x. They don't use these arrows. We write them without the arrow, but you need to understand that you have to do the inner one first. The inner integration, this should be done before the outer one. Sometimes you can switch between them. So we have the values here for CD, this is y. So y is just between CD and x between AB. If I do switch between these two, it's okay, but I need to do what? dx, dy, dx, dy. So I had to switch between the variables I'm doing the integration with respect to. Now the idea in general, what I need you to do, sometimes they give you the region for x and y. It's like a rectangular region here, and we need to do the integration with over this region. This is the notation they usually use. So it's the double integral over the region for f of xy dA. So we're integrating the area, okay, over this region from x equals AB to y equals CD. And this is the double integral. Now, what I need you just to practice before we move to this double integral, I need you to think about simple integration questions, okay, something indefinite. Let's say I need to find the integration. Let's say this is number 1. If you need to find the integration for xy dx, so here for you, what's the variable x? What's the constant with here? It's y. So I have only one variable x, and y is the constant. If I need to find this integration, it should be equals to what? X squared over 2y. You see y, I did nothing for it, plus c. Let's say the same question. I have it as the integration of xy, but this time dy. So this time you leave x as it is and you integrate y as y squared over 2 plus c. So as you see, just if you have two variables and you need to find the integration with respect to one of them, the other one will act as a constant term. Let's say try with something else. Let's say you have the integration of anything. We have like x squared sine of y plus e to the power of x squared. And I need to find the integration with dy with respect to y. This should be equals to what? The first function, x squared, is a constant, so it remains the same. Sine of y, okay, it's a function, it's with respect to y. So what's the integration for sine of y? We know this is negative cosine of y. And then plus, it's not multiplication of two functions. X squared is a constant now. Now e to the power of x squared. If it's with respect to x, by the way, we don't know how to integrate this, but this is luckily with respect to y. So e to the power of x squared is basically a constant, just like any number, 2, 3. So the integration will be e to the power of x squared y. And finally, you add your constant plus c. So this is what I need you to think about, just how to do the integration as you look at with respect to what you consider the other one as a constant. Okay, so this is just like practicing before we start the integration. Let's do one more. So let's say that you have the integration of anything. Let's say I have len of xy minus cosine 2x. And we're gonna do the integration with respect to x dx. Okay, so this should be equals to what? Len xy. I need the derivative with respect to x. So the derivative should be equals to what? You think about it now as len 2x, let's say. A constant with x. Any constant, ax. So what should be the derivative here equals? A over ax, okay? So here I'll do the same. This is basically y over xy. And minus the cosine with respect to x. So this is half sine 2x plus c. This is y. I could just cancel them. And this is 1 over x. 1 over x, okay? Now let's move to our examples. Here I'm trying just to prepare you how to do the integration with one variable, and you just consider the other one as constant there. Now see something like this. This is usually the form of the question you have. Remember, in this section, we're going to cover in Calc 2 only introduction. We're not going to go deep. I need you just only to have an idea what do you mean by double integral, how to solve some simple questions on double integral. And this will be the only section we cover out of chapter 13. If you were just later on, you're going to take Calc 3, you're going to just work more with these chapters 12 and 13. Now for this question, this is the double integral over the region for the function 6x squared plus 4xy cubed dA. Now what you need to do, you'll write it as double integral, and this is the function 6x squared plus 4xy to the power of 3. Now you need to decide to start working with x first or with y. Do I choose dx dy or dy dx? It depends which one will be easier for you to start with. So I look at this function. If I start with x or y, it makes no difference, honestly, in this case. They have the same level of difficulty, so it makes no difference with me which one to start with. Okay, I'll keep it like this, dx dy. Now you need to be careful. We started with x, so this is the inner one, the one that we'll start with. So the boundaries here, they should be for x. So what do I need to use in the inner one? This is the values for x. So x goes from 0 to 2. Now the next one will be y. So I'll leave it as from 1 to 4. You see how did I write the integration? So firstly, I wrote it just with no boundaries, nothing. And then I have to check. It's easier to start with x or start with y. Here it's honestly the same difficulty level. They are all polynomials. No issues. So it makes no difference. If you start with x, remember that the inner integration should be all with respect to x. dx, these values should be for x. The next one should be y. Now how do we start? We start with the inner integration. So you leave the one outside with nothing. No need just to interfere with the one inside. I need to deal with the one inside. So what's the integration here? It's with respect to x. So this is 6x to the power 3 over 3. So this is 2x to the power 3. Plus here, y power 3 is a constant for us. For x, it's basically x squared to x squared. And you need to do the substitution from where to where, the values for x. It goes from 0 to 2. And after I'm done with this substitution, the outer one will be dy. Okay, we're still dealing with the one inside. So this one should be equals to what? The integration from 1 to 4. You could do the calculation for this part here inside. It should be equals to what? Remember, you're replacing what? X. This is what we're replacing. We're trying to replace x. Okay, let's try. So if I replace the value for x here, So this is, you replace x with 2, so this is 2 to the power 3, 8 times 2, 16. I need to keep y here. So this is, we did for x, this is y power 3. Okay, so replace x with 2, so this is 16 plus 4 times 2, so this is 8 y to the power of 3. If I replace 0, this will be 0, this will be 0. So that's it. This is the first integration. Now we need to continue with dy. Okay, do the integration now with respect to y. This is equals to what? 16y plus 2y to the power of 4. And again, I need to do the substitution from 1 to 4. Okay, from 1 to 4. If I do the replacement, and you can just easily find the calculation, it will be equals to 558. If you switch the operation, you didn't follow just what I've done, you did y before x, you'll get exactly the same result. Or else you did something wrong. It should be the same result. Okay, so this is the idea. Now let's try one more, another question. Sometimes there's some students, they feel more comfortable to start with the inner one alone. So they do it on the side and then they have the result again with the second integral. It's okay, but it's more it's more important to get used on this format for later on. Now see the second question. This one here, they did it with respect. Yeah, they started with x also here. We did what? We did x first. Okay, same thing. Now let's try another question. Sometimes we don't have all of the boundaries as constant only. So maybe the region is defined as part of it as constant term, only normal interval, and the other one could be functions. So maybe we'll have the region between two continuous functions like g1, g2, and x between a and b. At that time, if you have anything like these regions as a function, remember always, now you have to let the inner one to be the function. It's not a choice. Before with constant, we had the choice, whatever we like, this one or that one. Now if there's any variable in the boundaries, you need to start with them. Okay? See now this question, like this. Now the tricky part here in these questions, you have the integration as a region. You need to decide between y equals to x, we have y equals to 0, and x equals to 4. First, I'll look at the function. You see, just this is really helpful to decide. I could play around with the boundaries and change them. First, I need to look at the function. What's easier for me, to start with x or y? Sin y, it makes no difference. I could do it for x or y easily. But this one is an issue. E to the power of x squared, we don't know its integration. Okay, we don't know its integration with respect to x. So that means it's much easier for us to start with what? With respect to y. So this is now helps me to decide that I have to start with y. Okay, I'll start with y. So now I'll do what? I'll begin with this. This is the double integration for 4e x squared minus 5 sine y. Now we said we'll start with y. So this is dy dx. Now I need the boundaries for y. Y equals to what? Y is between 0 and x, clearly. Which one is larger? So this is the 0. Y equals to 0, and this is y equals to x. So clearly y equals to x is larger. So I need just to start from 0 to x. Now what should be the boundaries for x now? We know for y, from 0 to x. Now for x itself, notice that y is equals to x and y equals to 0. So that means x equals to 0. So now x can be from 0 to 4. Okay, this is important. Just how did we fix the boundaries? So I decided that it's much better to start with y because I easily can find the integration, but if it's with respect to x, I don't know how to integrate e to the power of x squared. And then y is already given from 0 to x. I consider which one is larger just to have a positive result. Okay, we have it from 0 to x. And then you look at x. They give you only 4. You need the other boundary, but they tell you that y is equals to x, so they have the same value. And y is equals to 0, then x is equals to 0. Now we have the integration. We'll start with how to evaluate this integration. Remember, we start always with the inner one. So I'll keep the one inside and let's work inside with dy. 4e to the power of x squared. This is a constant now with respect to y. So what should be the integration? 4e x squared y minus, I'll move to the second one. This is a function of y. So what's the integration of 5y, sine of y? This is negative cosine. And I have negative already, so this is plus 5 cosine of y. Now I need to substitute the boundaries for y from 0 to x. And after I'm done, I'll do it again with dx. Okay, let's replace this one inside. So you see the one outside, I'll keep it till the end. Now try to replace x. What do you replace? Remember, you substitute y. So each y, I need to replace it with x. So what do I have? 4x e to the power of x squared plus 5 cosine of x. Okay. Good. 5 cosine of x. Now minus 0. I need y to be 0. So here 0, it will be cancelled out this term. With y 0, this is cancelled out. Here it should be cosine of 0, which is equals to 1, minus, so this is negative 5. Now this is the function. I need to find its integration with respect now to x. After you're done with y, you need now to move to do it with respect to x. Okay, that's good. Now with respect to x, this is supposed to be equals to what? Now x is a function. This can be done easily by substitution. You can easily see it as or using substitution. So this is equals to e to the power of x squared. Okay, this is with respect to x. Plus 5 cosine. This is plus 5 sine of x. Minus 5x. And then we substitute from 0 to 4. You can use your calculator here. And this is equals approximately equals 1.78 times 10 to the power of 7. Okay, that's it. Let's try one more. You see, this is the region, the graph of the region. Now, how did we take the points? This is y equals to x. This is 4. This is y equals to 0, which is the x-axis. Now, let's try this one. 1.6. This is our last example here. Again, this is double integral. I know that I have to do what? This is doubled. Same function. 2xy squared plus 2y cosine of x. Now let's try to decide. So I look at the function. Just think. If it's with respect to x, do I have any issue? This can be done. This can be done. No issues. If it's with respect to y, also no issues. So in this one, it makes no difference. I could start x or y. Both of them works fine. So let's say I started with x. Okay, what should be the function? Let's think about the values for x. You see here, anytime you have in the boundaries a function, it's an alarm. That means I need to start the function inside. So the inner integral should be the one involves the variable, not the outer one. Okay, this is x. What x equals to? X equals to 0. And y equals to 3. Y equals radical x. They didn't give me any other x. So if I think about the graph of this function, this is square root of x. It looks something like this. And I have x equals to 0. This is x equals to 0. And this is square root of x. and I have y equals to 3. Where's y equals to 3? This is square root. This is, let's say, y equals to 3, this line. This is y equals to 3. This point of intersection between radical x and y equals to 3, this is supposed to be 9. And this is the region we're talking about. That's it. Okay, how did I find 9? Just make them equals to each other. Radical x equals to 3, so x equals to 9. Okay, that's good. Now I see the region that I need to work with. What should be the boundaries now? Think about x first. So x, I need to do it from where to where if I need to consider x first. Look, y equals radical x. So x equals to what? Y squared. If I need to have x first, I'll start with 0 to y squared. Then y. What should be y? Y, it's from 3 and y equals radical x. Y equals radical x, but x is 0. If x is equals to 0, what should be y as radical x? It should be equals to 0. Then the boundaries for y is from 0 to 3. Okay. So we saw the region, and how did I just decide what should be the boundaries? Now we need just to move to how to find the integration again. So this is equals to, I'll keep the outer one as it is, and I'll deal with the one inside. Now the one inside, it's with respect to x. So x is the variable, y for me, I think about it as the constant term. So 2x, its integration is x squared, and I have y squared, plus 2y cosine of x. Cosine is the variable now. What's the integration for cosine? Sine. I'll leave 2y as it is. 2y sine of x. And then here I need to replace from 0 to y squared. Remember, this is important. We always replace what? You replace the variable you're working with. You replace x only. Don't touch y. So this is equals to what? From 0 to 3. Now I replace y squared. Each x, I replace it with y squared. This is x squared, y squared. So this is now y to the power of y to the power of 4. Plus 2y sine of y. Minus 0, think about the 0. So this is should be 0, sine 0, 0, nothing. It's only 0. And now I need to repeat the integration, but with respect to y. So this is now equals to what? If you do the integration with respect to y, so I have, yes, here I have x. This is supposed to be y squared squared. This is y to the power of 4 times y squared. This is y to the power of 6 plus 2y sine y squared. Remember, I'm changing x with y squared. So this is what we need to get. Now let's do the integration. So this is now y to the power of 7 over 7 minus the integration here with respect to y. Notice this is by substitution. This is like substitution. So what's the u substitution? So u squared, y squared is u. Its derivative is already outside. So this is basically supposed to be a negative cosine y squared. And then you replace from 0 to 3 for y. If you do the replacements, you'll get the value equals approximately 314.3. Okay, hopefully the idea is clear. This is a type of questions that we usually see a good number of mistakes with this question. So I advise you to practice more. Try just to try it yourself. Now what I'll do with you, we have the solution already here. I need you to try to switch the order between x and y. So if you try with y first, what will be different? Okay, think about the integration. If I start with y, I'll change the order here. Okay, I'll erase this. I'll erase this. Assume that you need to start with y first. What do you change in this case? Y first. Another important notice you need always to consider. If there's a variable, one of the boundaries, you need to start with the variable inside. Okay, so I have y. Where do I start from y? Y equals to 3, or you look at the graph. If you're able to graph, it's much easier. So y equals to 3, and if x is equals to 0, then y equals to 0, right? Y equal radical x, radical 0, 0. So, so I need to do what? We need to do x first. So x from 0 to what? We need to do y first, sorry. We decided to use y first. So y should be first. So I need to start from 3. There's a 3 and radical x. Which one you start with? 3 is higher. So I'll start with radical x down and 3 up. And then I'll move to x. What's the values for x? I have x equals to 0, right? And x equals to 9. We saw if y is equals to 3, then x equals to 9. So x goes from 0 to 9. If you do this integration, you'll get exactly the same result. Okay, it would be 314.3. 314.3. Hopefully this is clear. I recommend that you try just practicing more. Try to resolve the question that we've done together today. Hide the solution, try it yourself. Play around with the variables, try to switch. See, do you get the same answer? So that's it for today. Take care. Bye-bye.